Hello everyone, I am Angad Singh, PhD scholar in the Department of Computer Science and Engineering at Ravindranath Tagore University, Bhopal, India. I am presenting my paper, Linguistic Feature Selection for Personality Trait Identification from Textual Data. Here is the abstract of the paper. Personality identification is a common and central problem in text processing. Sensing personality is helpful for various purposes. For example, estimating users' personality before providing them with any services is necessary. Individuality is essential in a person's nature in every outlook. For example, in text writing. And this is where this paper is focused on. When you try to identify personality traits from textual data, the core challenge is the low accuracy achieved that this paper tried to address by a solution which we call LFSPTI. This is the technique that first finds feature based on mutual information, F-statistics, principal component analysis, and chi-square. Then it utilizes a genetic algorithm to select the high-ranked features from all the features. This way, it reduces the number of features. The results demonstrate that LFSPTI gives better introduction. Personality is the combination of all those activities that can be discovered by actual observation over a long period of time to give useful information. Personality describes a person from multiple perspectives, such as thoughts, behavior, beliefs, feelings, and emotions. According to psychology, every personality has a significant influence such that it affects life priorities, well-being, health, and many other choices in daily life. Automation of personality trait recognition has multiple applications, such as human resource management, decision-making, marketing strategy, tourism, mental health, and forensics. There are various personality trait models, out of which this paper works on the Big Five personality trait model. The focus of this work is the prediction of personality traits from textual data. There are various machine learning models that can predict the personality traits of an individual. Feature selection techniques have been applied in some recent works to increase accuracy. However, low accuracy remains a core challenge that this paper tries to address. So it integrates feature extraction from textual data, feature selection, and genetic algorithm. Related work. In recent times, many research studies have based on machine learning and deep learning approaches for personality recognition. Personality recognition from social networks is widely accepted, with Facebook prominently considering sentiment analysis. There are various research that focus on LICWC features, time-related features, SNA features, and more. One of the research work, Linguistic Etiquette, was a major work demonstrating that composed language is unique for every individual's personality traits, perhaps recognized by using language cues. LIWC is a mechanism of text analysis that counts the frequency of various groups of words in a given text. Investigators have discovered notable correlations between personality traits and linguistic characteristics. All the above research studies predicted personality using social media platforms in English using the Big Five personality model. Maris et al. Use conversational and text database in experiments with LIWC for Big Five personality trait model. The Maris criterion relies on the correlation between personality traits and linguistic feature for textual dataset. It mined 102 features, which are 14 features for MRC-PD, from MRC Psycholinguistic Database and 88 LIWC features from LIWC mechanism. The major contributions of this research studies are mentioned below. This work presents a unique approach called linguistic feature selection for personality trait identification for mining features. It extracts features like LIWC, linguistic inquiry word count, MRC, and MPET from the textual datasets. It applies feature selection methods, F-statistic, chi-square, mutual information, and principal component analysis. It uses the genetic algorithm to select high-rank features from all the feature subsets. Next, it applies machine learning models, SVM, that is support vector machine, logistic regression, decision tree, to the selected feature set. The result on the popular essay dataset show that the LFSPTI method's accuracy outperforms the current personality identification methods. So what we are doing in this method, it is explained here. The method relies on MRC, MPET, LIWC features, F-statistics, chi-square, mutual information, and principal component analysis. So in the paper, the first two subsections related to method describe these concepts, and the finally last subsection describe the LFSPTI method. We used MRC, MPET, and LIWC linguistic features for this method. The MRC features include the number of letters, syllables, intonation, consciousness, familiarity ratings. MPET is a text analysis tool that draws meaning between words and phrases and generates new lexical categories on demand from a small set of seed words. LICW features like word count, words per sentence, positive emotions, anger, work, job, home, number of commas, colon, apostrophes, similar to the Mayer's baseline. The feature selection techniques that we utilize are F-statistics, chi-square, mutual information, and principal component analysis. This figure demonstrates the working of the proposed method. We have the input training data set given in terms of X and Y. X is the feature space, Y is our label space. So first we extract features from this textual data, and we extract three different features: LIWC features, MRC features, and MPET features. Next, we combine these features into a single set and form this extracted data set. Now, we apply three different feature selection method: F-statistics, chi-square, mutual information, and one more PC. These feature selection methods give four different aspects of the given data set. Now, these features contain different kinds of features. So what we want to select the higher rank feature out of these four different aspects of the data set, for which we are applying the genetic algorithm that will find the high rank features from the data set. And finally, it will form the high rank feature data set on which we are going to train the classifier. This is what you will obtain the HY classifier. Now, this classifier may be support vector machine, it may be logistic regression, it may be decision tree, or any other classifier. In our work, we utilize three classifiers and also compare among them. And the classifiers are support vector machine, decision tree, and logistic regression. This figure demonstrates how the testing process will be done. Testing process is going to be nearly similar to the training process. This is what we have: the input test data set, where we will simply utilize the feature space, and this Y will be used to compare what exact test result we are obtaining. So first we will extract the features from this feature space X. In the same way, we will extract LIWC feature, MRC feature, and MPET features. We will combine these features. Now, genetic algorithm has already given us which features are the highest rank features or which features are the most useful feature. We will select only those features in this process where we are selecting high rank features. From this, we will create the extracted data set, which is going to be the test data set. This will be given to the classifier that we have trained in the previous step. It will give us the output. Now we will compare this output with the given Y value to check how accurate our classifier is working. This slide demonstrates the algorithm for LFSPTI. This is the training algorithm for LFSPTI. So we have input data set XY, where X is going to be a matrix with n cross m dimension. Y is the class vector, which composed of 0 and 1. So it will have n by 1 dimensions. We are having different features which we are denoting as P1 up to Pm. F is the number of features for every feature list, and capital F is the selected relevant number of features. The output that we want from this is the best selected feature subset, which we are going to denote by PF for all the given classes. XL is the LIWC feature from X. XM is the MRC feature from X. XE is the empath feature from X. So we will first extract these three features, and in the next step number 4, we will combine all these features. It will give us the combined feature dataset. Now this capital PF is the best selected feature subset for different personality traits. So we will run this for loop for every personality trait once. Now, initially, the selected feature set is null. Chi is said to be null, and all the other feature sets are null. We will run this loop for 1 to m for every feature of the given input data set. And we will form these 4 different feature set for this given feature set. Now, this will be repeated for m number of times. So we will have this array. So it will contain n m number of features for every perspective. Now, we would like to select the high rank features subset from these given 4 feature sets, for which we are going to apply the genetic algorithm, and we will save these features in the selected feature subset. This is the procedure that we are using. So we just want capital F number of features in our final data set. So this is what we are doing. We are applying this method, this for loop, which is varying from 1 to F. We are creating a pool of all these feature subsets. And what we will do, till this pool is not null, we will keep repeating this while loop. So P is this step demonstrates that we will select and delete a random feature from the pool. We will train a classifier applying this P temp as the feature set and get its accuracy denoted by accuracy 1. If this accuracy 1 is greater than the earlier accuracy, then we will include this into this P temp and we will increment the count by 1. If the count is equal to the number of features that we want to select, we will simply break this while loop. Otherwise, we will keep repeating this feature, this loop. Finally, we have HY, which will give the train classifier for the wire personality. And accordingly, we will obtain these subset of feature for the wire personality. We will complete this. So we will have, finally, we will have this PF, which is the selected set of features for our input data set. Now, we have used 3 different classifiers, SVM, LR, and decision tree, using the genetic selection technique. These are the various different parameters that we have utilized for SVM, for logistic regression, and for decision tree. Similarly, for genetic algorithm, we are keeping the size of population as 50, probability of mutation as 0.01, maximum number of generation at 100. We have divided the data set using 5-fold cross-validation and experiments with repeated 10 times, and the average values are reported in the paper. Now, what we come to the conclusion that the LFSPTI performs better than all the other existing methods. Till now, the best method that we have studied given the best result for 59.26, 61.32, 59.06, 58.94, and 63.03 for EXT, NU, AGR, CON, and open personality traits. When we compare LFSPTI, it gives us the accuracy of 59.26 as compared to, it is better than 59.26. we obtain 61.83, better than 61.32. We obtain 60.01, better than 59.06. We obtain 59.62, better than 58.94. And finally, for openness, we obtain 64.18, better than the 63.03. So in all the given personality trait, we have improved it, and the percentage are given. For first personality trait, improvement is 1.18%. For second personality trait, it is 0.83%. For third personality trait, it is 1.61%. For fourth personality trait, it is 1.15%. And finally, for fifth personality trait, it is 1.82%. So overall, this gives us the better information, better prediction performance than all the given competing methods. Also, we are not only comparing the performance on individual personality. When we compare it with the overall mean of this, the best competing method that gives us the result was 60.28, whereas we are able to obtain an accuracy of 60.62. So it is an overall increase of 1.39% in the prediction accuracy. All these results confirm that LFSPTI is a superior method compared to all the other methods, all the competing methods. So it means that LFSPTI is a better method when we are using a genetic-based feature selection technique for improving the classification of personality traits. Conclusion and future work. So basically what we did in this work, we have addressed the low security challenge in personality prediction from textual dataset. We have proposed a method LFSPTI that works on the big 5 personality trait model, and it given us better result when we have discarded 90% of the results, 90% of the features. In the future, since we come to know that evolutionary algorithm like genetic algorithm can give you a better result when you are applying it on feature selections, we can apply mimetic algorithm for selecting the best feature instead of the genetic algorithm. Also, we have used 4 different aspects of the data sets. In the future, we would like to add some more aspect of the data set and would like to test whether those aspects gives us better results or not. So this is what we will do in future work. Thank you.